Hey guys, welcome back to AlgoYogi. We are doing linked list series, and our next problem in the list is add two numbers. So let's go to the problem on LeetCode. It says you are given two non-empty linked list, just like in the example, and two non-negative integers representing two non-negative integers. So basically, 2, 4, 3 is representing the backward number 342, and this is 465. All right, so we gotta like imagine them like reversed. So you're going from the last digit to the first digit, and now we're gonna add these together to return basically another list. So since the other list will also appear in the same order, basically going from first node to the last node, so we don't really need to worry about the order here. It's just for our own convenience, because when we add these numbers, we start adding them from the basically the last digit, and then we move forward to the first the 10th digit, 100th digit, or like so over. So let me just show you guys like how we, and then we also just need to return the list as well as the result, not the added numbers represented by the other two lists, L1 and L2. So here in this example, we're going to add 342. This is what I meant. 465. When we are adding these, we're basically taking these two digits. Imagine they were represented like the other way, then it would be difficult for us. We will have to convert them to a number and then do it. So here we know that we're going to represent each digit by a node. So we could even brute force solution would be just convert this list to a number, 2, 4, 3, reverse it, 342, and then convert this number. That would become 5, 6, 4, reverse it, so that will become 4, 6, 5, add them, that will make it 7, 0, 8. I'm just like writing it like 5, 2, 7, 6, 4, 10, 0, and then 3, 4, 7, and plus 1, carry over 8. So this is what we get. Once we get this, we reverse this, so 708, and then using these digits we create a list and then return that. All right, but we're not gonna do that. That's time taking and stupid. We could just traverse this list, these two lists simultaneously, and create our final list. That would be the sum of these digits together. That particular node we will be creating will be basically adding these two together and passing on the carry to the next. So when we are adding these two, we're getting 7. Do we have any carryover? We don't. Then we're gonna move forward in L1 and L2. Then we're gonna add these two. We get basically 4 plus 6 is 10, but then we just only put 0 here, and the carryover is basically passed on to our next two values. And this is where we're gonna have add the carryover. So 4, 3, 7, and then 8 over here. And remember that in order to it might happen there's these lists are not of same length. In this case they are, but they might not be, and that's also we need to take care. And how we're going to take care is basically if it were to 7, then we would just only take the carryover to the next list and then just append that as 7 over here. So whichever list does not finishes up, or like once gets over, one of the list is consumed completely, then we gotta keep moving with the remaining list or carryover. Imagine it might happen that both lists end. Let's say there was a case when these two, this value was 6, this value was 6, and this value was like let's say 3. Then there was one carry over, so we are adding 6, 3, 9 and one more, then this will become 0, and carry is passed on, 1 carry plus 1, so that also has to come here, right? It will make 4-digit integer now, and the list length will be 4. So this is that also we need to take care. And I think in terms of code, it will be super simple. Super simple. All right, let's write it down. Move this little bit like this so that we have more space. So first thing first, since we need to return a list, I'm gonna create a dummy node. I'm gonna just give it any value, don't care. So let's say 0, and then I'm gonna have a current pointer pointing to dummy. All right, and in the end I'll just return dummy.next, which will be my current pointer. Current pointer will take care of everything in terms of creating this new list with the addition of all the respective nodes from L1 and L2. All right, so what I gotta do is I'm gonna keep looping in. If L1 is there, also we're gonna have a carry variable to carry is initially going to be 0, and then if L1 exists or L2 exists or my carry, as we just talked about carry being so important, that even if the list end and carry stays, we gotta still make a node with carry and append that to the list. All right, then now what we gotta do is let's take care of this scenario where you know what, let's come back to it later. What we gotta do is first have let's say a new value created. So I'm going to call it value. That will come from L1.val plus L2.val plus carry. All right, and then using these two, I am creating a list node, and then I am setting my cur.next. But before that, this is basically a node that I just created, and that would be my current.next. All right, cur.next would be this. And now I'm gonna, but wait a second. Let's not create the node right now, because we need to deal with this value. Because see, the node would be just the first digit of this sum, right? So the node, I'm gonna basically say my new carry would be whatever the value I just created divided by 10, so that I'm basically getting if the sum were to be 12, 1, 2, then carry would be 1, so that I'm dividing it by 10, so that would be just 1 integer division basically. Now is when I can create the node using this value, but not the entire value, only the first digit. So that would be mod 10. All right, so that would be my node would be list node sending in the value but mod 10. All right, so that will be my actual valid node. And let me just, instead of creating it, let me just call it current.next equals to this node, and that's it. Carry has been taken care. But what about the case when L1 and L2 or either of these are ending and we only need its value? How about if they don't exist? Let's say if L1 is let's say should I just check if not L1? I would say if not L1, I'm gonna check it like this. If not L1, then L1, I'm just gonna call it value. You know what? I'm just gonna call it, let's say L1 value would be L1 dot val. If L1, else it's gonna be 0. And same thing I'll do with L2. And you guys absolutely have perfect idea what I'm doing, so I'm not gonna explain it again and again. And that's it. And we will replace these thing basically with the L1 value plus L2 value. So basically, if they're not present, that particular list ended, or it wasn't present in first place, then we're just adding 0, no value. All right, that's it. Now that's been taken care of very beautifully. What do we do now? Now current pointers next is the list, new list node, and that's it. What do we do now? Just move our pointers. So L1 equals to L1 dot next, L2 equals to L2 dot next, and I could have just moved it over here, cur dot next. All right, then that's it. We finally return, as I said, this dummy, since I wanted to have a reference that I would return, because at the end of the day we returned the head of the list, that this new list we created, and we were using the current pointer. Now current pointer is the end of the list, the last node. It might be at the none, but we return, that's why we had this reference. So we could return dummy.next, which would be basically the first pointer. All right, current is dummy dot. There's just one more thing that I want to check. All right, this is the first node we're creating, so it's basically a valid thing. We are setting cur dot next, not the cur. All right, so this is awesome. I think let's zoom out and run this beautiful solution on examples. All right, we gotta check, right? We're moving. If L1 dot next, then only you move it ahead, and if L2 dot next, then only you want to basically move ahead. Otherwise yeah, I think what we will never be at a place when it will, if L1, right? Because we have to reach where L1 becomes none as well, so that's why 0 could be assigned, right? Live debugging, guys, live debugging. All right, then let's submit and then talk about the time complexity. All right, then it would be basically space complexity is big of n, because or you know whatever the sum will be, it could be maximum length from L1 and L2. You know, sometimes like if you're adding, and only just it could go one more level, one more index digit more than what these max length of L1 or L2 was. What I meant is if something was let's say L1 was 4 digit long, L2 was 6 digit long, then my final list would be 6 plus 1 digit long max, because let's say there was a carryover that was passing on, and then that would make in the end 1. All right, then time complexity would be big of n or max of n plus m, whatever And I'm just in this case like n is just max of L1 or L2. I'm just trying to say that. And space complexity would be big of n as well. And remember, this n comes from treating maximum length from L1 or L2. So n is basically n equals to max of L1 or L2. These are the L1 and L2 length. L1 and L2 are the length of both of these lists. All right, then let's go back to AlgoYogi and mark this problem solved. Okay, until then, bye bye.